Hey guys, today we're going to cover topic 2.3, which talks about parallel lines and transversals. Parallel lines are coplanar lines that do not intersect. So which basically means that they're going to be continuing in the same direction forever since they're never going to touch. And we use these arrows on the line to indicate that lines are parallel. In symbolic notation, we use two vertical lines, so we can say something like line AB is parallel to line CD. So again, those two vertical lines means that they're parallel. Parallel planes are planes that do not intersect. So it's very similar like lines. Okay, they're never going to touch. In symbolic notation, we can say plane J is parallel to plane K. Skew lines are non-coplanar lines that do not intersect. So they're not in the same plane and they're not parallel. A good example here would be like segment TP and segment QR. So like in this 2D image, it looks like they're going to touch, but you have to be able to visualize this in 3D. Another good example is segment WV and segment UQ. So although here it looks like my lines are touching because of the way that I drew them, you have to remember that this is a rectangular prism. Okay. So those lines are really not touching because they're not in the same plane. And lastly, another good example would be like segment SP and segment VR. All right, now let's try some examples. Number 1, part A wants us to name all the segments that are parallel to segment AE. So remember, they're going in the same direction as AE. So those 3 segments were parallel to segment AE. And you have to remember that you can name it also the other way around. It didn't necessarily have to be segment GC. You could have said CG. Now we want to give 2 examples of parallel planes. I'm going to pick plane FBC. Remember that you didn't have to use those 3 letters. You just use any 3 letters to name a plane. I could have easily said GCB. So that plane is parallel to plane HEA. So it's the other square on the other side. Here I have plane BFE. It is parallel to plane CGH. Now we want to name all the segments that are skewed to GH. So remember, these are not in the same plane and they're not parallel. I have segment BC. I have segment EA. I have segment. And lastly, I have segment BF. I do want to point out a common mistake. I think a common mistake would be to choose something like AB. Okay, because you're going to think, oh, well, those are not in the same plane. But you have to remember that they cannot be parallel. And segment HG and AB, they're going in the same direction. Those are parallel segments, so we cannot choose that. Example number 2, we want to first name all the segments parallel to segment JK. Segment OP is the only line that's parallel to segment JK. Now we want to name all the segments parallel to segment NS. So we had all those segments that were going in the same direction as segment NS. Now we want to name a plane that's parallel to plane JKL. All right, so plane JKL is this 5-sided polygon, which is called a pentagon. So the only plane parallel to that, which means it's going in the same direction as that, is the other pentagon. So I'm going to call that plane QRS. All right, and lastly, we want to name 4 segments that are skewed to RQ. So remember, they're not in the same plane and they're not parallel. All right, now let's talk about a transversal. A transversal is a line that intersects 2 or more lines. So in this example, if you notice, line T goes through line L and line M. So line T is your transversal. So the transversals create relationships for angles. First, we have corresponding angles. They are angles that are in the same side of the transversal and in the same position. I would say angle 1 and angle 5 are corresponding. If you focus on the first 4 set of angles, notice how angle 1 is on that top left corner. And on that second set of angles, okay, angle 5 is on that top left corner. So that's what it means by same position. Same thing here, we have angles 2 and angle 6 are corresponding. Again, out of the first 4 sets, notice how angle 2 is on that top right-hand corner. And on the second set, angle 6 is in that same location, same position. Now we have alternate interior angles. So the interior region is everything that's inside the two lines that are not the transversal. So we have angles 3, 4, 5, and 6 that are all in the interior part. So alternate interior angles are in the interior, they're non-adjacent, so they can't be side by side, and they're on opposite sides of the transversal. So if one is on the left side of the line, the other one has to be on the right side. A good example is angles 4 and 6. And then we have angles 3 and 5 are also alternate interior. So next we have alternate exterior angles. Those are, the exterior region is everything outside the two lines. So everything outside of L and M. Okay, so angles 1, 2, 8, and 7 are part of the exterior. And same thing here. They have to be non-adjacent and they can't be on the same side of the transversal. They have to be on opposite sides. So we can say like 2 and 8, those are alternate exterior angles. We also have angles 1 and 7. We also have same side interior angles. You can also say consecutive, but I like to say same side because I feel like it makes more sense to a lot of students. So all that is angles that are on the interior, okay? And they're on the same side of the transversal. So remember, T is my transversal. Okay, so notice how 4 and 5, they are on the same side of the line, okay, on the same side of T, line T, and they're both in the interior part. And we have the same thing with angles 3 and 6. On these next two examples, we're just going to name the type of angle relationship. For example, corresponding, alternate interior, alternate exterior, or same side interior. If there is no relationship, you can write none. So on this next example, the transversal can change depending on which set of angles you're comparing. For example, if you are comparing angles 5 and 13, then the transversal would be the line that's going through both of those angles, which would be line B. If you are comparing angles 9 and 16, okay, that's part D here, then the transversal is considered line D. That's the line that's going through both of those other lines. And then that would make these alternate exterior angles. All right, let's try one more to angles 2 and 10. Here the transversal is line A. That's the line that's going through both of those angles. And therefore, they would be corresponding. Again, so corresponding, same location, same position. Out of those four angles, angle 2 is on the top right corner. Out of the bottom 4, angle 10 is on the top right corner. If you were stuck on part H and part I with angle 6 and 11 and angle 4 and 13, notice how there's no transversal that's going through those angles. Therefore, there is no relationship. All right, guys, that's all I got. Thanks for watching.